And we are back. Welcome to the deep dive.
We are.
We're officially kicking off season 4 right now, and I have to say, the whole the vibe is shifting.
Oh, yeah.
If you were with us for season 3, we spent a lot of time down here, in the mud, looking at regional battlegrounds, mountains, rivers, all that.
Right. Borders on Earth.
But for season 4, we are trading those regional battlegrounds for universal frontiers. We are looking up.
It is a massive shift in scope, for sure. But what we're going to find out today is that, well, while the altitude has changed, human behavior really hasn't. We're just moving the chessboard into a vacuum.
That's the part that really surprised me.
Yeah.
To guide us, we're Unpacking the Future of Geography by Tim Marshall. And I'll be honest, when I first saw the title, I thought, space politics, isn't that just Star Wars?
It is our swords and aliens, yeah.
Exactly. But Marshall is adamant.
Yeah.
This is not science fiction. This is astropolitics.
Astropolitics. It's a term you're going to be hearing a lot more. It is essentially the application of geography, politics, and strategy to space. The core argument here is that we're moving from an era of just exploration, planting flags, taking photos, feeling good about humanity,
Right.
to an era of claiming.
Yeah.
And, well, inevitably, the rivalries we have down here are spilling upward.
That idea of claiming is what we need to dig into. We usually think of space as this, infinite void where borders don't exist.
Yeah.
But the source argues that space actually has geography,
It does.
which to me sounds like a total oxymoron.
Yeah.
Geography implies earth, ground, terrain. How do you have geography and nothingness?
And that is the single biggest misconception about space, that it's just empty blackness. It really isn't.
Right.
Space has terrain just like Earth. It has gravitational corridors that acts like shipping lanes. It has radiation belts you have to avoid, almost like reefs or shoals in an ocean.
Wow.
And has these oceans of vast distance that are just incredibly difficult to cross. So just like on Earth, this geography dictates strategy.
So if I'm a strategist, I'm not just looking at a star chart. I'm looking for the high ground.
Precisely. The source highlights the work of a strategist named Everett Dolman. He took the famous heartland theory of geopolitics.
We've talked about that one before.
Yeah, which was all about controlling the core of Eurasia to dominate the world. And he adapted it for orbit.
I actually have his maxim here. And I have to say, it sounds like something a Bond villain would broadcast right before holding the world ransom.
It is a bit dramatic, I'll give you that.
Let me just read this. Who controls low Earth orbit controls near-Earth space. Who controls near-Earth space dominates Terra.
There it is.
Who dominates Terra determines the destiny of humankind.
Yeah.
Dominates Terra. That's us. That's my house. Is this actual military doctrine or just a guy with a flair for the theatrical?
I mean, it's a bit of both, but the logic is sound. If you just strip away the destiny of humankind part and look at the mechanics.
Okay.
If you control low Earth orbit, you control the satellites. You control the satellites, you control navigation, banking, surveillance, communication. Everything on Earth. You have the ultimate high ground. Right.
Dr. Bledden Bowen calls this the cosmic coastline.
The cosmic coastline. I like that image much better than dominating Terra.
It helps to visualize it, right? Think of Earth's orbit as a shoreline. If you're land power, you project influence out into the coastal waters.
Yeah.
In this case, powerful nations project influence up into the coastal waters of space. And just like the British Navy dominated the 19th century by controlling the seas, space powers will dominate the 21st by controlling orbit.
But before you can even patrol the coastline, you have to get off the beach. And this is where the book gets into the launch divide. I had no idea how much physics discriminates based on where you are on the map.
Physics is incredibly unfair in that regard.
Yeah.
It dictates that it's much, much easier and significantly cheaper to launch a rocket near the equator.
And this is about the spin of the Earth, right?
It is. I mean, think about it. The Earth is spinning towards the east. At the equator, that spin is fastest, about 1,669 kilometers per hour.
Okay.
So if you launch a rocket eastward from the equator, you get that speed as a free boost. A free push. But, okay, 1,600 kilometers per hour. That doesn't sound like that much when a rocket needs to hit, 28,000 to get to orbit?
It sounds small, but in rocketry, every single gram counts. That free boost means you need less fuel to reach escape velocity.
I see.
Less fuel means you can carry a heavier payload. More satellites, more cargo, more people. But if you launch from far north, like Russia or the UK, you just don't get that boost. You have to burn way more fuel just to catch up.
Which totally explains the geography of launch sites. The U.S. launches from Florida. That's as far south as they can get. Europe uses French Guiana.
Exactly. French Guiana is prime real estate.
Yeah.
But look at a country like China. Their main launch sites are inland, so they have to launch over their own territory, which is risky.
Right.
That's why you see China now eyeing places like Djibouti.
Exactly.
Exactly.
Yeah.
Djibouti in Africa for a launch base. They want that equatorial access.
So we're seeing a new class system emerge. On Earth, we talk about the digital divide. Is this the launch divide?
That is a perfect way to put it. You have the haves,
Mm.
the spacefaring powers with the right geography and tech, and the have-nots, the client states who have to pay rent just to put a satellite up.
Wow.
If you don't have a coast on the cosmic coastline, you are totally dependent on those who do.
Okay, so let's say we pay the rent, we get our rocket, we launch, we arrive in low Earth orbit. This is that first heartland Dolman was talking about. From reading the source, it sounds like LEO is becoming the 405 freeway at rush hour.
Crowded is an understatement. LEO is the area from about 160 kilometers to 2,000 kilometers up. This is where the ISS lives, it's where the spy satellites are, and crucially, it's where mega constellations like Starlink are parking thousands of satellites.
And this leads to the big risk. Debris. We've all seen the movie Gravity. Is that realistic, or is that just Hollywood hyping up the danger?
The physics in the movie were, let's say, a bit exaggerated, but the concept is terrifyingly real. It's called the Kessler syndrome.
Walk us through that.
Imagine a cascade effect. One satellite blows up. Maybe a battery fails. Maybe it collides with something. It shatters into thousands of pieces of shrapnel.
Okay.
In the vacuum of space, that shrapnel doesn't slow down. It just keeps whizzing around the Earth at 28,000 kilometers per hour.
And a bullet moves at, what, 2,000?
Right. So a tiny screw moving at 28,000 kilometers per hour hits another satellite with the force of a hand grenade. That satellite shatters.
Oh, no.
Now you have more debris, hitting more satellites. If this cascades, LEO becomes an impassable minefield. We wouldn't just lose GPS and internet, we would be trapped. No rocket could safely leave Earth.
We'd be imprisoned on our own planet by our own garbage.
For centuries, potentially.
Yeah.
So strategic planners are looking past LEO. They are looking for safer, more stable places to park. And this brings us to one of the coolest concepts in the book, Lagrange points.
The parking lots of space.
Yes. In space, gravity is always pulling you somewhere. You have to burn fuel to fight it. But Lagrange points are these unique spots where the gravity of two large bodies, like the Earth and the Sun or the Earth and the Moon, it all just cancels out perfectly.
So if I park my satellite there, it just floats.
It stays put with minimal effort. It's incredibly valuable real estate. Take L1, which is between the Earth and the Sun. That's the perfect spot for a solar observatory.
Uninterrupted view.
Exactly. But the real strategic eyes are on L2.
That's the one on the other side of the moon, right?
Correct. It sits behind the moon relative to Earth. If you put a satellite there, you have a direct line of sight to the so-called dark side of the moon.
And why does that matter?
Because the far side of the moon is a complete radio dead zone for Earth. We can't see it or hear it. But if China lands a rover on the far side, which they have done, and they put a relay satellite at L2, which they also have done, they can operate entirely out of our sight.
It creates a strategic blind spot for the West. Which brings us to the ultimate prize in this new geography, the moon itself. Not just anywhere. It seems like everyone, the U.S. with Artemis, the Chinese, the Russians, is obsessed with the lunar South Pole. Why there? Apollo landed at the equator. What's wrong with the equator?
The equator is, geologically speaking, a desert. It's dry and exposed. The South Pole, well, that is an oasis. The geography of the South Pole Aitken Basin is unique in the entire solar system.
This is where we get those incredibly poetic names, the peaks of eternal light. It sounds like it's out of a fantasy novel.
It does, but it's pure geometry. Because of the tilt of the moon, there are mountain peaks at the South Pole that are bathed in sunlight for 80, maybe 90% of the time.
Constant solar power. You don't have to deal with that 2-week-long lunar night that freezes everything to death.
Exactly. Power is survival. But right next to these peaks, you have the permanently shadowed craters. These are deep holes that haven't seen a single photon of sunlight for billions of years.
So temperatures there drop to, what was it, minus 238 degrees Celsius?
Colder than Pluto. And because they're so cold, they act as cold traps. We believe they contain massive amounts of water ice.
And water is the gold rush.
Water is more valuable than gold. I mean, sure, astronauts can drink it, but the real value is chemistry. If you split water H2O, you get hydrogen and oxygen. Liquid hydrogen is rocket fuel. Liquid oxygen allows it to burn.
So the moon isn't just a destination, it's a gas station.
That is the perfect analogy. Think about gravity wells. Earth is at the bottom of a very deep one. Climbing out is incredibly expensive.
All right.
The moon has 1/6 the gravity. If you can refuel on the moon, you can launch missions to Mars or the asteroid belt for a tiny fraction of the cost.
So whoever controls those craters at the South Pole controls the logistics for the rest of the solar system.
Precisely. And that leads to this resource paradox. We
What-
often hear tech billionaires say space has infinite resources. And, theoretically, the universe does. But practically, the accessible resources are incredibly scarce.
This is the first come, first served problem.
Think about those peaks of eternal light. There aren't thousands of them. There are a handful. Maybe only a few square kilometers of prime real estate where you get both the constant sun and easy access to the ice craters.
So if China sets up a base on peak A and the U.S. sets up a base on peak B,
You run out of peaks.
you just run out of peaks.
And you can't just move next door. The resources, the water, the helium-3 they accumulated over billions of years, they are not renewable. Once you mine an ice crater, it's gone. It's a finite resource rush in an infinite void.
You mentioned helium-3. I feel like I see this in headlines every few years, touted as the miracle energy source. Is that real or is that just funding hype?
It's potential reality. Helium-3 is an isotope. It's rare on Earth, but it's abundant on the moon. And theoretically, it could be used in nuclear fusion reactors to provide clean, safe, limitless energy.
I mean, China's chief scientist claimed lunar helium-3 could solve our energy needs for 10,000 years.
He did, but you used the key word there, theoretically. We don't even have working fusion reactors on Earth yet.
Right, so we're fighting over fuel for an engine we haven't even built.
That is the healthy skepticism to have. We are decades away from using it. But in geopolitics, you don't wait for the technology to be perfect before you secure the supply. The race to claim the mining sites is happening now.
And this rush is creating a massive headache for the lawyers. We have this legal framework, the Outer Space Treaty of 1967, but reading the source, it feels like it was written for a totally different world.
It was. It was written when only 2 countries could reach orbit, and the main fear was Soviet nukes in space. So the treaty says space is the province of all mankind. No nukes, no claiming sovereign territory.
Which sounds nice. We come in peace.
Oh.
But it doesn't really mention mining, does it?
It's incredibly vague on exploitation. It allows for exploration. But if I'm a private company and I spend billions to mine a ton of platinum on the moon, do I own that platinum? Or does all mankind own it?
And if all mankind owns it, why would I ever spend the billions to go get it?
Exactly. So countries are starting to ignore the old treaty and make up their own rules. We're seeing a fragmentation of space law into competing blocks. On one side, you have the U.S.-led Artemis Accords.
These are the bilateral agreements the U.S. is signing with other countries.
Right. And they introduce this concept of safety zones. The U.S. says, look, we aren't claiming territory, but if we set up a base, we need a safety zone around it so nobody interferes.
Wait, isn't that just a loophole? If I draw a 50-kilometer safety zone around the best water ice crater and say, keep out, I've effectively claimed it.
That is exactly the Russian and Chinese argument. They call the Artemis Accords a land grab dressed up in diplomatic language. Russia has called it an invasion of the moon.
So they're forming their own bloc in response.
Yes, the ILRS, the International Lunar Research Station. They plan to have a rival base by 2036.
So we're going to have 2 separate legal systems on the moon. This brings up that scenario in the book that I found both hilarious and terrifying. The space mogul Frankenstein.
The jurisdiction nightmare.
Let's play this out. I'm a private citizen. I'm on a space hotel module built by Japan, but launched by an American rocket, and it's owned by a company in Luxembourg. I get to a fight. I stab someone. Who arrests me?
The scary answer is nobody knows. Under the current treaty, the launching state retains jurisdiction, so technically the U.S. might be responsible. But if you're in a Japanese module attached to an international station, it's a total legal gray area.
And it gets darker. What if a company decides to build a biotech lab in orbit to do experiments that are illegal on Earth? Who has the authority to go up there and shut them down?
Currently, no one. We are relying on norms that are rapidly eroding, and when law erodes, force usually steps in.
Which brings us to the sharper end of the stick. Militarization. The book has a great phrase, the flag follows the trade.
It's a historical constant. Merchant ships sailed to the Spice Islands, pirates attacked them, so the Navy followed to protect the trade.
Right.
We're seeing the exact same pattern in space. The U.S. Space Force isn't just a logo, it's the modern Navy.
I noticed their language shifting too. Space Force isn't just watching Earth anymore. They're talking about cislunar space, that vast area between Earth and the Moon.
They're developing the Cislunar Highway Patrol System, CHPS. They are preparing to patrol the trade routes to the moon, because if the economy moves there, the military has to follow.
And the weapons are already there. We're not talking about X-Wings, but we are talking about ASAT's anti-satellite weapons.
Yes. The US, China, Russia, and India have all demonstrated the ability to shoot down their own satellites with missiles. It's a flex. If I can hit my satellite, I can hit yours.
But there's also dual-use technology, which I find even more insidious.
This is the perfect cover. Imagine you build a satellite with a robotic arm. You say, this is to grab space debris and clean up orbit. A noble cause, right?
Sure, we just talked about how bad the debris problem is.
But if that same satellite maneuvers up to an enemy satellite and snaps off its solar panel, it's a weapon. And you can't tell the difference until it attacks. It's a garbage man with a knife.
Then there are the threats that don't even involve blowing things up. The internet apocalypse. This one really stuck with me.
This is the scenario that keeps planners awake. It could be a nuclear detonation or just a massive solar flare, a natural event. If a flare hits the Earth, it could fry the electronics of the entire ELEO satellite network.
And most people would think, oh no, I can't check Instagram. But it's so much deeper.
It's catastrophic. It's not just the internet, it's the GPS timing signal. The entire global banking system relies on GPS timestamps. Power grids rely on it to synchronize flow. If you lose LEO, you lose the economy. Logistics stop. Food doesn't move.
The estimated cost is billions per day, and yet we have no backup plan.
We have built our entire modern civilization on a scaffolding in space that is incredibly fragile, and we have almost no redundancy.
It really paints a picture of vulnerability. We're rushing up there with all our ambition, but we're bringing all our old baggage, our wars, our greed, our politics with us.
That is the summary of astropolitics. We're moving from a brief period of scientific cooperation, like the ISS, where Russians and Americans hugged in zero-G to competitive rivalry. The big three, USA, China, Russia, are racing to set the norms.
So what's the verdict? Is space going to be a commons or a patchwork of fenced-off territories?
The winners of this race will decide. If the US wins, we get the Artemis Accords. If China wins, we get their rules. But history suggests it won't be a commons. Geography just invites ownership.
Before we wrap up, I want to leave the listener with that provocative thought from the end of the book. We've been talking about rockets, this whole time explosions, fuel, all that cost. But Marshall throws a curveball. The space elevator.
Yes, the dream of bypassing the rocket equation entirely.
He jokes about cables made of spider silk or chewing gum, but the physics is actually theoretical, right?
The physics holds up. It's the material science that's the problem. But the concept is anchoring a cable to the equator and letting the Earth's spin hold it up. If we could do it, it would just crash the cost of space travel.
It would turn a perilous journey into a commute.
It would. And that changes the entire math. If space becomes cheap, it becomes mass market. Which brings us to the final question. If we open those floodgates, will humanity's expansion into the stars outgrow our history of conflict? Or are we just exporting our wars to a much larger battlefield?
Marshall seems to think the overview effect, looking back and seeing one Earth, might save us. But looking at the safety zones and kill vehicles we talked about today, I'm not so sure.
I'm an optimist about technology, but a realist about human nature. I wouldn't bet against conflict just yet.
A sobering but vital perspective to start the season. That is all for this deep dive into the future of geography. We'll see you next time as we continue our journey through the universal frontiers. Thanks for listening.
Keep looking up.